All right, so the last part of the review we're going to look at is how do you solve rational equations. So to solve, what we want to do is get rid of the fractions. Okay, that's the simplest way I can say it. Eliminate the fractions. Now the part we have to figure out is how do we do that? To eliminate the fractions, you're going to multiply by the LCD, least common denominator. So to solve, eliminate the fractions by multiplying by the LCD. So first, I will do an example with just numbers so we can see how to do it without any letters. I'll do an example without any letters at the bottom, at least. So let's say you have this. X over 3 plus 5 over 2 equals 8x over 6. The only thing that's making that equation a little bit complicated to solve is it's all fractions. If we could get rid of the fractions, I think you would find it's pretty easy. To get rid of these, we're going to multiply everything by the LCD. The LCD is a number that 3, 2, and 6 all divide into. Let me give you an example of a number, 60. That's not the LCD. Okay? It's a common denominator, but it's not the smallest one. I'm trying to find the smallest number I can that all three of those divide into. Does anyone think they see the smallest number? Yep. 6. And I'm not going to think of it as 6. I want to think of it as 3 times 2. Okay? Does everyone agree 3 times 2 is 6 though? Yep. Okay. So we're going to multiply all three of those things I put in parentheses by 6. But I'm going to think of 6 as 3 times 2. So multiply this by 6, multiply this by 6, and multiply this by 6.
Why are we doing it 3 times 2, not just 6?
You'll see right now, because this is exactly what's going to happen up above.
Because if you do 3 times 2, then it eliminates the 3 on the first one, eliminates the 2 on the second one, and then eliminates the 6 altogether.
So yeah, now you're going to cross out what you can, and this is exactly what's going to happen when you have letters. You have a divide by 3 in the bottom. Well, I still want you to be able to read it. And you have a times 3 in the top. That's gone. You have a divide by 2 in the bottom. You have a times by 2 in the top. Now, what about on the right side?
You can get rid of both.
Right, you have a 6 in the bottom, and you have a times 6 in the top. So now, do out what you have left. What's x times 2?
2x.
2x. What's positive 5? That symbol goes with that number. Positive 5 times 3.
15.
15. And now what's on the right side?
8x.
8x. Now we have a much simpler equation to solve than what we started with. It's the same equation, but it's a simpler version. That's the whole goal, to come up with something that's the same, but simpler. Now, if we finished it, we'd have 15 equals 6x. If you bring the 2x to the other side, and then divide by 6. That's not really the part I was focused on. This is the part I want you to understand. Okay. Any questions what we did there? Okay, so now,
How did you get 15 over 6?
I just divided each side by the number in front of the x.
Because you'd subtract 2 to the other side, so you get 6x.
Yeah.
And then you divide by 6.
Okay.
Oh.
Okay. I'm going to erase that so I have room to do the work for this one now. But first, does everybody have?
So the answer is just 15 over 6? Or
Yeah, I mean, you could reduce it. Again, getting the answer right there isn't really important.
Alright.
What's important is this.
Alright.
That's the important part. So any questions on just that part that I circled? Okay, so I can erase that part? Okay. So now, let's look at this one. What's making this one difficult is there are fractions. If we can get rid of all of them, it's going to become a lot easier. When we get rid of them, this is probably going to turn into a quadratic, which we can either factor or use quadratic formula. Okay. We have to find a denominator that this, and that would all divide into without a remainder. Does anybody see what all three of those could divide into? Yeah?
X minus 2 and x plus 3.
Yeah. If you took what Aiden just said, x minus 2, x plus 3, you could divide this into it, and you wouldn't get a remainder. You could divide this into it, and you wouldn't get a remainder, because it would cancel out. And you could divide this into it, and you wouldn't get a remainder. So usually what you end up multiplying by is this and that. Those are the two things you end up multiplying by. Right, so we're going to multiply all three of those by x minus 2, x plus 3, and something should cancel out each time. Okay, so watch what happens. This is like the step when we multiplied everything by 3 times 2. Right? It's kind of what we're doing right now. So x minus 2, x plus 3, x minus 2, x plus 3. When I do that in the first fraction, what cancels out?
X minus 2.
Right, you're dividing by x minus 2, multiplying by x minus 2. How about the second fraction?
X plus 3.
You're dividing by x plus 3, multiplying by x plus 3. Third fraction,
Well,
all of it. Dividing by that, and then you're multiplying by that. Okay, so now we have to write down whatever we have left. What you have left is usually distributive. 5 times that, times that.
5x plus 15.
5x plus 15. Okay, now this is the part some people make a mistake with. This plus sign and that 2 go together.
Plus 2x minus 4.
Yeah. So if it was a minus in front there, you need to use the minus when you distribute. And what did you say that would be?
2x minus
2x minus 4. And on the right side, everything canceled, so all we're left with is
7.
7. Okay. Is this one a quadratic? What do you think? Is that a quadratic equation? No. It doesn't have an exponent of 2. This is just a linear equation that you'd see in Algebra 1. Oh, now we got to get x by itself. Okay. What should we do on the left side? Yep. And when you combine like terms, what's 5x plus 2x?
7.
7x. What's 15 minus 4?
11.
11. Okay.
Subtract 11.
We subtract 11 from both sides. 7 minus 11 gives me negative 4. And my last step to get x by itself.
Divide both halves, both sides by 7.
Divide both sides by 7. So what's our final answer?
Negative 4 over 7.
Negative 4 over 7. Now we have to check and make sure that works. But there's only there's only two numbers that wouldn't work here. What are the two numbers that if you tried to fill them back in?
2 and negative 3.
2 and negative 3. Is that a 2?
Nope.
No. Is that a negative 3?
Nope.
No. Then it's fine. Question on that?
So if we check it and it equals 0, then we can't use it.
Right. Let's say you solved it. Will, can you? It's kind of stop crinkling it. Yeah, thanks. If you check it and plug it back in, like say you got negative 3 as an answer. If you put negative 3 in, you divide by 0. That means it's extraneous. Did I mention that word before? Okay. That means you can't use it. You need to cross it out. I have another one. Do people want to try another one just like that? All right. So why don't you guys try that one? Okay, so I'll give you a couple minutes, and I'll walk around and see how we're doing. Okay. So again, this one is a problem with 3 fractions. What did we multiply each fraction by?
X minus 1, x plus 3.
X minus 1, x plus 3. Okay, so we're going to do that in all 3 spots. What will cancel in the first one when we do that?
X minus 1.
X minus 1. Second one? X plus 3. And the third one?
All.
Yep, that's all going to cancel. All right, what we have left is a distributive property. 1 times x plus 3 gives me what?
1x plus 3.
Positive 2 times that. 2x minus 2. And what's on the other side? 1. Okay. Combine like terms. 1x plus 2x.
3x minus 3x plus 1.
3 minus 2 is plus 1.
Subtract the 1.
Subtract the 1 on each side.
And then divide by 3.
And what does that give me first?
0.
3x.
3x equals 0.
No.
Divide by 3 and it'd be 0.
And then you get x equals 0. Is the number we just got a 1?
Nope.
Is it a negative 3?
Nope.
Nope, then it's fine. Okay, well, it's not extraneous. If you made a mistake like you did 3 minus 2 and you wrote 2, well then yeah, I would be wrong.
Why is it not 0 over 3? Why is it just 0?
To simplify.
0 divided by 3 is 0. Yeah. Okay. So again, just one answer. Let's look at this one. Okay, so we're going to start just by parentheses around everything right away. What's everything going to get multiplied by here?
X plus 2x minus 3.
Right, you got to cancel those denominators, so you got to multiply by x plus 2, x minus 3. So x plus 2, x minus 3.
This one's called quadratic, right?
And x plus 2, x minus 3. Okay, what is going to cancel in the first one?
The x plus 2.
Okay, so that's gone. Second one,
And then the x minus 3.
x minus 3. And the third one,
No.
nothing. That's why it's going to be quadratic. Nothing canceled out. Okay, so let's handle the left side. Do that first. What do you get when you do 2 times x minus 3?
2x minus 6.
Minus 6. How about positive 1 times x plus 2?
Maybe x plus 2?
Yeah, it would just be x plus 2. Now the right side is 1 times all of this.
So just the same.
X plus 2, x minus 3.
Yep. So now we have to FOIL this out. We're just going to multiply it by 1, so it's not going to change. The 1 doesn't change anything. But this needs to be done out. What's x times x?
X squared.
X squared.
There's your two answers, x to the second power. What's x times negative 3?
Negative 3x.
And x times 2?
2x.
And then negative
What's negative
6.
3x plus 2x?
Negative 1x.
Negative 1x. And 2 times negative 3?
Negative.
Negative 6.
Okay. So now, why is that a quadratic?
Because it has
A square.
Has x squared in it. When we're solving a quadratic, we want to get everything on one side. Right? And we generally like this to be positive. So I would leave the x squared where it is, move everything else around it to the right side.
Wait, how did you get negative x and not like negative 3x?
Well, it's negative 3x plus 2x. Negative 3 plus 2
Oh, you said.
is negative 1. Yep, just add them up. All right, let's combine here first. What's 2x and 1x?
3x.
3x. What's
Minus
negative
4.
6 plus 2?
Negative.
Okay, so that's a little better. Now let's put everything on the right, because if we're going to factor it, we definitely want to keep that positive. If we move it to the left, it's going to become negative. So don't move it. How would we move the 3x to the other side?
Subtract 3x and add 4.
So we subtract the 3x, that's gone. Yep, add the 4. That's gone. What's on the left side now?
0.
0, nothing. It's gone. Okay. Are we doing anything to the x squared? No. How about negative 1x plus negative 3x?
Negative 4.
Negative 4x. And what's negative 6
Minus 2.
plus 4 is minus 2.
Is that your answer?
Well, we have to solve, when we're done, this is our answer. If you haven't got x by itself yet, then no, you don't have an answer.
So you have to factor it.
Yeah, we could try factoring. That's not going to work. So we're not going to be able to factor it. So if you can't factor it, what do you have to do? Yep, you got to do quadratic formula. Okay, what's, just make sure we know what we're going to plug in. Okay, what's the A?
1.
1. What's B?
Negative 4.
And what's C?
Negative 2.
Okay. Before we use the formula, I know we've gone over it. Can someone remind me what is the formula?
Negative b plus or minus square root of 4 or b squared minus 4ac
Divide.
all over 2
2a.
over 2a.
Yeah. That's our formula.
Just kidding.
Okay. What's negative B in this case?
Negative 4.
Negative
Negative 4.
So it'd be 4.
So 4. What's B squared?
Negative 16.
16 minus 4 times what's A? 1 times what's C?
Negative 2.
Negative 2. All divided by
2.
2A. So now once we simplify that, that's our answer. Okay, so 4 plus or minus, what's 4 times 1?
4.
4 times negative 2. So we have 16 minus, and when you do everything I just circled, that's negative 8.
This would be plus 8.
Right, so you have two minuses. When you combine them, they're going to become a plus. All right. So now, what's 16 plus 8? 24. And 24, that can be simplified. What are two numbers you can multiply to get 24? And one of them is a number you can take a square root of.
6 and 4.
Yes. You can break up 24 as 4 times 6. So this part right here, this isn't algebra. This is more just like arithmetic to simplify a square root. The algebra, we're done. Okay, we've got x by itself. We're just simplifying the answer as much as we can.
Just go up to the formula real quick.
Mhm. So everyone agrees 4 times 6 is 24?
Mhm.
Okay. What's the square root of 4?
2.
2. That's how you write the square root of 24. 2 square root 6. Okay, so we get 4 plus or minus 2 square root 6 divided by 2. And what do you notice now about every number on the outside of the root?
2.
They're all divisible by 2. But again, this doesn't always happen where you get to reduce it and then everything is divisible by 2, but in this case it is. How many times does 2 go into 2? And how many times does 2 go into 4?
Twice.
Twice. So you're left with 2 plus or minus 1 times the square root of 6
Over 1.
is just square root of 6. And yeah, you don't have to put it over 1 because dividing by 1 doesn't change it. If that number wasn't a 1, like let's say that number was a 3, then yes, I would need that number. Okay, so I put my answers over there, but that's your 2 answers. 2 plus the square root of 6 and 2 minus the square root of 6. So as far as a quadratic, that's about the worst one you could have because it didn't factor and we had every possible simplification we had to do was in that problem. Reducing and simplifying a root. So that's as bad as a quadratic could get.
So, we would do it that way whenever, like, if you go back to the original problem, whenever that, the thing it's equal to, the bottom is the same as those two, you have to do it that way.
You mean use the quadratic formula?
I mean, like the original, the last example, we just did the multiply thing to the bottom on all of them.
Right, we multiplied everything by the 2 things that were right there.
Yeah.
You do the same thing here. Multiply everything by the 2 things right there.
Okay.
So we still follow the same step as the last process, the last part. Yeah. Yeah. Okay, so any questions on that? Okay. This will be the last one we do by hand, and then we'll finish up with the calculator. Okay. So this one's actually a lot easier than all the other ones, but it looks different, so I think sometimes people get confused. But
Do you
it's,
just times or multiply them both by x minus 3?
yes, there's only one denominator there, x minus 3. You're multiplying by everything, by the denominators you see right there. Well, the only denominator I see in this one is x minus 3. So multiply by x minus 3.
5x minus 15.
So let's start with the left. What happens there?
It cancels out.
Those cancel out. And what are you left with on the left side?
4x plus 2.
4x plus 2. And now the right side, just be careful, it is distributive.
5x minus 15.
Yeah. And now we just get x by itself. How would we bring all the x's over to the right side?
Minus 4. X.
Minus 4x. 4x minus 4x is gone. What's 5x minus 4x? 1x.
And 15.
And now add 15.
X equals 17.
And x is 17. Yep.
So that is-
I told you it was a lot easier than the last one.
We should all do that on the test.
You might have one like that.
We should have like 4 and then
We should have like however many.
Or like that.
just get rid of
I would cry.
Give me all like
Oh.
EVM ones.
So let's look at the last one. So this is one that, because the numerator is a cubic, there's a lot of terms there. It's a lot more complicated than one like that.
Yippee!
So this one, we're going to graph.
Will you, on the test, will you tell us to solve it with the calculator or not?
You're supposed to know.
Or is it?
No, I don't know.
I mean, if it doesn't fit, like, these all have the same kind of pattern. I think this one, and this one, they all look kind of the same. If it doesn't look like one of those three, and
And it has
has
a cube on
really
it.
high exponents on it, that's when you know you need the calculator.
Okay.
Yeah.
Or we just don't need a calculator at all.
Okay, how, somebody tell me what I would type to put that in Y1. Parenthesis, that's the key. If you don't put that, it's going to come out wrong. Now, okay, so minus 4x squared plus 6x minus 8. Okay, now what would I do? Divide.
Parentheses.
Again, that's the important piece. You need parenthesis again.
X squared minus 2.
Okay, so that's the left side. Now what?
Would you do on Y2 1?
Yeah, I'm going to put 1 on Y2 if I ever get this typed in the correct way. There we go.
So it'd be 1.
So we're going to put 1. So now we're going to hit zoom. What would be a good starting point? 6. Just kind of a side question. What kind of EBA would that have? Degree in the top is a 3, degree in the bottom is a 2. It's one more. What do we?
Slant.
It's a slant. Good. That's a slant. You can see the slant right there.
And how did you find the intercept of them?
Now we
You
gotta
use
see where they
second
go.
calc,
Second calc.
the intersect, so
Intersect.
5, and then you do the red line and then the blue line.
Yep, right now I'm not on the part of the blue one I want to be. I don't know if I need to be, but I should probably just move my cursor over there anyway, just in case. So move your cursor over there, hit enter 3 times. And now be careful about what number you write down. In this equation, what letter are you solving for?
X.
X. Then that is the letter you should be writing down, not 1. The answer is 3.8. 2 decimal places, 3.8.
So you put 1 in the y equals, the second y equals thing?
Yep, that's what I put in. Any questions on that?
Nope.
So if you can like graph a question like that, then can't we just graph the ones mine like that too and get the right answer?
No.
Why?
Because if you graph it, does the calculator ever give you an intersect that looks like
Will
that?
it be the same, like
Oh, I guess you're right.
The calculator would give you some decimal, like 2 point, whatever, 3.4156.
Would you accept?
But if
that?
I ask for the exact answer, the only way to get it is the quadratic formula, and that is something I might ask for.
Okay.
So, the calculator can't give you an exact answer.
Well, shucks.
Can you print out the review pages, the review
Yeah,
packet
print it out.
Yeah. that's good.
Any question on that?
No.
Okay.
Yeah.
So those 3 reviews, that covers everything that's going to be on.
Is it the same
Just
exact
tomorrow.
test as last week, or is
Yes.
the numbers
They're not still gonna
different?
say-
I'm going to double check it and make sure there was no questions on there that I really don't like after what we reviewed this week. And then go from
Yeah, we
there.
should.
All of them?
Those questions out.
All of them?